Good morning to another present here. I am Dr. Anand Kumar, General Chair of BDCC 2020. On behalf of the BDCC 2020 Organizing Committee, I am honored and delighted to welcome you to the third EAI International Conference on Big Data Innovation for Sustainable Cognitive Computing. This conference has brought researchers, developers, and practitioners around the world who are leveraging and developing the big data technology. The theme of BDCC 2020 is Big Data Innovation for Sustainable Data Science Technology. The technical program of BDCC 2020 consists of 17 full papers in oral presentation sessions at the conference track. Aside from the high-quality technical paper presentations, the technical program also features two renowned keynote speakers. So I would like to welcome Professor John Liu, Professor, Department of Computer Science, School of Computing and Engineering, Center for Planning, Autonomy and Representation of Knowledge, University of Huddersfield, United Kingdom. And also I would like to welcome Dr. Monik Sharma, Department of Computer Science and Applications, Dave University, India. As a conference chair of BDCC 2020, I know that the success of the conference depends ultimately on the many people who have worked with us in planning and organizing both the technical program and supporting social arrangements. I am privileged to work with distinguished colleagues on the conference planning committee who have volunteered their time to put together a comprehensive program covering key issues we faced across each of the areas. In particular, we thank the EAI European Alliance for Innovation for their wise advice and brilliant suggestion on organizing the technical programs. Thanks to program committee for their thorough and timely reviewing of the papers. And also I would like to thank our sponsor, Sri Ishwar College of Engineering, Coimbatore, Tamil Nadu, India. We strongly believe that BDCC 2020 conference provide a good forum for all researchers, developers, and practitioners to discuss all science and technology aspects that are relevant to the big data industry. So once again, we welcome you to this conference and look forward to your participation. Thank you.
Dear ladies and gentlemen, let me welcome you to EAI BDCC 2020 conference held in this virtual interactive setting. I am Karolina Marcinova, and I would like to address all of you on behalf of EAI and BDCC 2020. Unfortunately, I'm not able to meet all of you in person, so I'm using this opportunity to address the organizing committee, the keynote speakers, the authors, and the participants on behalf of EAI. I would like to thank all of you for being a part of this conference and for your involvement with EAI. In particular, I would like to thank the whole organizing committee for their hard and excellent work throughout the whole process of the conference preparation. Lastly, let me use this message to invite you to join us again at EAI BDCC 2021. More information about the next edition will soon be available on the website. Should you be interested in becoming a part of next year's organizing committee or the technical program committee, please do not hesitate to contact me at my email address below. Similarly, if you're interested in discussing other possible cooperation, a conference, a workshop, or a new event altogether, please contact me at my email address as well. Now, my colleague Michal will present you with what EAI does, who we are, and how you can get involved in our various activities. Thank you for your attention and enjoy EAI BDCC 2020.
Hi everyone, my name is Michal Dudic. I'm the Community Manager at EAI, European Alliance for Innovation. It's my pleasure to welcome you at this conference and say a few words about who we are and what we can do for you and your research career. In short, EAI is a global community for a greener, healthier, and smarter world. As of today, we are home to more than 60,000 members from 167 countries, and we reach out to tens of thousands of subscribers. As an organization, we are non-profit from day one, and what is most important to us is that we remain open to all researchers from all around the world thanks to membership that is completely free. We organize more than 100 events annually, such as this conference, and we do so in publishing partnership with Springer. I said in the beginning that EAI is a community, so let's talk about what that means and what it means for you. To put it briefly, we give our members a platform that builds their research. We do it with 3 main online community services where members come together to help each other write a better paper, get an objective review, and get recognized fairly. The 3 services in question are EAI Compass, Community Review, and EAI Index. Firstly, EAI Compass is an online app where you can meet and connect with new colleagues and get feedback on your paper as well as your presentation. In addition to that, it lets you download all full papers that will be presented at this conference, and you can vote on your favorite presentations as well as see everyone who is here and connect with them. You can do this right now if you go to EAI Compass website, compass.eai.eu. Next, we are improving the classic conference review process with community review. It has already been in use at all our events since 2019, and we were very excited to hear a lot of positive feedback from program committee members regarding the reliability and the speed of the community review. Let's talk briefly about what community review does. Essentially, it is a website that shows abstracts of papers that are right in the middle of the review process, as long as the authors allow it, of course, and all EAI members may then bid to review specific papers. When they submit their bid, they put in their bio and their qualifications, which are sent to the program committee, who can then decide whether or not this bidder is qualified to review the paper they bid on. This relatively easy access to review opportunities means that bidders really need to put their best foot forward if they wish to be selected, which improves the quality of the entire review process. At the end of the day, this benefits you, the author. And last but not least, let me tell you a thing or two about EAI Index. EAI Index is our credit-based evaluation system that we rolled out this year to all of our conferences and journals that allow you to climb the global ranks of EAI community and get recognized for your work. It calculates a number value for most actions you make, such as getting your paper accepted or submitting a review, and these numbers accumulate for 12 months. At the end of this 12-month period, we put together a ladder of all EAI members, and the ones at the top receive a nomination to one of the membership ranks: senior member, distinguished member, or fellow. For each action that is eligible for EAI Index credits, we'll look at the quality of your action as it was evaluated by another member of the community, such as, for example, the review score of your submission. To make sure that the system is fair to newcomers, every 12 months the credit count gets erased, the ones at the top receive their nominations, and every member starts at 0 for the following 12 months. And finally, Smart Submit is a collaboration feature that is coming later this year. It will allow you to submit your research ideas and your work-in-progress abstracts to get the kind of help and feedback you're looking for. Maybe you are looking for co-authors, maybe you would like to find a mentor or a mentee, or maybe you want to find out how the community feels about your idea. This is what Smart Submit is designed for. Ultimately, it's about helping you write a better paper and increasing your chances of getting accepted. Again, we will be launching this feature later this year, so stay tuned. And so I'm going to leave you with many different ways to get engaged at different levels. There are lots of opportunities in many of our events and publications, which means many ways to connect with people and collaborate. You may learn more about everything I just talked about at our website, eai.eu. These services exist to help you and to make your lives easier, so we encourage you to send us your comments, ideas, and feedback to community@eai.eu. And if you're interested in volunteering and contributing, you can let us know at the same email address. Don't forget that you can use EAI Compass to vote on presentations in real time to determine which ones are the best, as well as to download all full papers that will be presented today. Just make sure that you log in using the same email address as the one you used to register to this conference. Thank you very much for your attention. Please enjoy the conference, and I hope we will see everyone online soon.
Hello everyone. Today we are going to talk about smart technology. versus smart applications, a huge challenge for both areas. Welcome, my name is John Lu, Department of Computer Science in the University of Huddersfield. If you come to Huddersfield, you're most welcome. For today's overview, first we're going to discuss the trend of application development. Secondly, mobile technology deployed. And finally, where we are and what conclusion we are drawing. For the trend of application development, there is a hot topic recently. It's called Global Software Development, that is GSD, supported by Scrum framework. The Scrum practices are mostly agreed as successful and effective method. The Scrum proved to be very flexible in making changes in development of software at any phase. Scrum teams are encouraged to contact each other regularly. Then the communication can be effective in a team. Scrum becomes popular and can be used for globally dispersed teams. It is therefore Scrum could be a better choice for the development of smart applications globally. So first we talk about smart applications and smart technology. Application always developed through a new technology, and then technology always developed based on a new knowledge. So the knowledge develop smart technology, and smart technology develop smart applications. Finally, we need to link to the smart methodologies. So this application technology will be used in the different sectors, such as education, engineering, business, and healthcare. The technology at this moment, we have web services, smartphones, cloud systems, for example, Amazon Web Services and Microsoft Cloud Systems. And then also we have latest platforms, for example, Zoom, Google Meeting, TeamViews, response systems. And then for this technology, especially helpful during the COVID-19 system will contribute to the communications and service for the people who are locked down or in the social distance situations. For the smartphones, we always link to the smart technologies. And then the smart technology enables smartphones to have smart utilizations. This utilization include messages, cameras, and navigations, or other accessories with other business, for example, mobile commerce, e-commerce, or e-business, online shoppings, online payment. Next example is smart learning. Smart learning must be linked to the smart technologies. And then the activities will be linked to the assessment, feedback, inspiration, and socialization, because the e-learning or online learning become the important activities for any educational communities. So, the mobile computing versus information technologies. Because mobile computing will link to the information resources and then link to the service providers through the internet. Use devices such as smartphones or some portable devices like laptop and then electronic small devices, PDAs, or some healthcare devices. So the challenges for these applications are interface, because people want to have friendly, simple, and interactive interface. And then they want to have an open conversational relationship. Next one, for the operations, they want to have minimal operations. For example, only simple press or simple click to get the results. So services, they want reliable, faster, and secure systems for their data service, storages, and retrieval uses. So this is challenges for the applications. Another challenge is big data introduced to the context. A few years ago is terabytes, but now gradually become petabytes and then gigabyte or exabyte. So the huge data is not just for the big data. Huge data, if we have good facilities, good hardware, the huge data is not issue for the big data. But the speed is a more difficult issue than the size. For example, sensor digital data streaming, business transactions, mobile data, Internet of Things. So they are faster and huge data communications. And then sensor in a wireless sensors network. For example, in a manufacturing production line and the web data transactions and the mobile phones, especially for the smartphone communications, WhatsApp is a good example, and the videos, cameras. And then for the business point of view, we have logistics supply chain, we have m-commerce, we have e-banking, we have e-finance, and enterprise resources planning as well. So the Internet of Things linked to the tracking, sales records, and the healthcare monitoring systems, and then GPS, spatial data, product flow path. The challenges from the real world. Data connections transfers. For example, from machines, in the machine, we have many sensors, instruments, actuators, and other devices. And then for the business transactions, we have orders from customers, suppliers receive orders, and then process orders and other transactions. And then from another applications, for example, voting, people just press the button, touch screens, and then vote what they would like to. And then planning, we have gamification, and huge animations, and huge graphic communications and images. The big data also linked to the different resources, because the data come from USB connections, and then data come from camera video captures. Also, data come from network systems, and then data come from mobile phones, and come from the detective instruments. So the data, the big data, always linked to the different resources. That is another issue for the big data science. Yes, different formats come from different resources and different software generators. But now, the formats also come from different actually data. For example, got text data, got message image data, we got documents data, we have got video audio data, we got RFID data, and also we have web pages and instant snapshots. All these data contribute to the different formats. And then the big data also linked to the information retrieval, because we need to use the technology of information retrieval to use and reuse these data and these resources for the different sectors, for example, manufacturing, social life, smart city, government, and education, business, finance, healthcare, police, social security, and also scientific research. They are doing, or they are generating huge big data, and they need information retrieval to reuse this data for their business purposes. The example of big data in the manufacturing industry. For one sensor with sampling rate 5 MHz, 1 hour data login file will be 144 GB. For 8 hours shift per day, one sensor will produce more than 1 terabyte data. For a production line, it could have hundreds in one location or millions of sensors at multiple locations in use. Multiple petabytes are usually achievable. So massive data sets are generated by the sensor data streaming. The data are constantly communicated between sensors and machines. Another example in education communities. For the course data and administration data. And then these data could generate huge size and massive speeds from the internet or from any network platforms. For example, The process from enrollments, attendance, feedback, and assessment. During the COVID-19, the enrollments, attendance, feedback, assessment are doing online. Students doing exams online, and students get feedback online, and attendance also recorded online. So these massive data sets are generated by these processes. The big data is also generated from the social communications. For example, they come from emails, text messages, chats, or from the tweet from Facebook. And then, in the academic communities, ResearchGate, LinkedIn also contribute to some data communications. And then all these social communications make some contributions for the big data generation. The data are constantly communicated between the communicators. This model is simply displayed the big data generated from the actions of request and response systems, and then the SD means subject domain, and RQI stands for the request sent from the device. RJ stands for specific response sent from the device as well. So this system can be as complex as possible. The case studies using applications. We introduce a model is called inspiration, understanding, and knowledge harvesting. To implement this model, we give students games to play, and then students play the game to get some basic understandings, and then once the student understood the subject knowledges, and then we give students some questions, and the students respond according to how much they have understood. And then we give students lectures, and students can use the concepts they learned from the games, and then they can use some experience when they answered their questions, and then they back to the lectures. They find that the learning is not so boring. They are interested in this interactive learning. And then after all this activity-based learning, and then we use tests or examinations to measure students' understanding. And then we call this is knowledge harvesting. And then after students have done the examinations, we get quantified results as displayed in the diagrams here. So these new methods are definitely put into strong impact on the traditional classrooms. Because in the traditional classrooms, students are just listeners, and then the teachers are always dominant the whole learning process. But in our methods, and then students just use technologies and to activate their thinking, and also to proactively discussing with the knowledge they want to learn and with the course they want to achieve a very good results. That is why they are interested in this new learning methods rather than the traditional classroom environment. And then, to implement these new models, new learning methods, we introduce response technology in the framework. The response technology basically is based on wireless communications, and then students can use their portable devices and receive questions triggered from the teachers, and then send their answers to the teachers, and the teacher acting as a receiver to receive students' answers, and then the server is just like a socket and communicate between the response and the triggers. And then, to be able to increase the usability of the systems, we design the system as ubiquitous as possible. And then we linked to the internet, we linked to the portable devices, and then we called it is wireless response systems. In practice, the teachers ask questions, and then students reply the questions, and then all the answers questions all go into the database. And then the researchers or lecturers, professors, they can retrieve this information or data to do the analyze and then to improve further performance. So this is an ongoing projects in the research group, and this application is called Smart Care Systems. The system especially benefit to the old people who has difficult in their mobilities, and then the system help these vulnerable people to check their temperature, check their light, and check the carbon dioxide densities in the rooms, and check the atmosphere pressures. And then the people, old people, they can check their heater, or they can use a device to control the heaters in the room. The temperature could be higher, could be lower, depends on the weather conditions. And then the people can use devices to automatically close the windows, doors, and fans. If in the summer, they can use electricity to drive their fans to make the rooms cooler. So they need to use these smart care systems to control these operations. And then this example is for the mobile learning applications, and then this application can be used for the school kids in learning physics, and then the students use portable devices, for example, smartphones, iPad, and portable PCs or laptops, and the teachers are using the desktop or laptops to control the process. The process has 3 steps. First, the selected question types. Question types could be text input or multiple choices. or download or upload some prepared questions. Second process is user input questions. Sometimes users want to input their questions instantly during the lectures. So students can know what questions we are going to answer for this lecture, or when the lecture finished and the students can test their understanding by answer very simple questions or very relevant questions for the lectures. And then next process is for the timing, because the big question could be using a longer time, and a small question could be using a short time, and this can be flexibly controlled by the teachers or lecturers. And then system can be used for mathematics, because for the natural science, the questions always have some absolute answers, because the answers could be set by the multiple choices or set by some text. The answer always very clear and absolute. However, for the social science, one question may have multiple answers. That is why the system can be set up for single answer or multiple answer, depends on which subject area and which part of sectors. So for social science or for science. To enable other students who come from different part of the world, they are not native speaker of English, they speak different languages, and then we think about the system should be linked to another part of the world, and then that is called internationalization. And then we implemented multiple languages such as Arabic, Polish, Turkish, French, and Italian, Romanian, Malaysian, all other languages, and people can use this language in their way. They don't have to translate from their language into English, from English to their language. There is no translation at all. Directly use native languages and by the native speakers. For example, this is Arabic language, and then the system has been implemented by the Arabic speaker. And then the Arabic students feel very, very happy about that, because they don't have to translate Arabic language into English and English into Arabic when they are learning, when they are studying in their country. So this intelligent systems has been developed, implemented, and then deployed by a number of people around the world and a number of subjects and countries. We're back to the very early stages of response technology in the systems. Initially, we said sender and responder, and then this is very simple, very pretty systems for the first generation response. However, only mobile apps is not enough for the wide range of users, and then we update the system into the further web-based, internet-based systems. So, the application has been used in the old and new, small and large countries in Europe, Asia, and the Middle East. This is a case study in industry training courses. The senior engineers, they want to update their qualification or update their knowledge. They use technologies to do their training, and then after training, they get qualifications. The several European countries use the systems to do their professional performance and professional improvement. The evaluation in the European university classrooms. The person who is doing this evaluation is a psychologist. She analyzed the responses from the female and from male students and their attitudes and their point of views about using the systems. So, in conclusion, smart technology plus smart methodology will be an outcome of smart applications. And then we start from the inspiration, investigation, and the innovation harvesting. Thank you. We have a large number of researchers in our research groups, and we have a number of doctors graduated from this research group, and they are professors, they are lecturers, they are working in the industries all over the world from different countries and come from different countries. Here are some resources if you are interested in some contents in the applications, or you are interested in some technologies. You can find these resources from Google Scholars or Scope or elsewhere, Science Director, searching academic search engines. Thank you.
Hi everyone, I'm here to present a paper on color-to-grayscale conversion for images with non-uniform chromatic distribution using multiple regression. We have a lot of historic documents, images which are with a lot of artifacts, and it is very difficult to extract the characters that are available in these documents. This has been a challenge to most of the researchers for more than a decade. We also have very recent documents which are scanned and which are also given for understanding what is written on these documents. Such challenges are always available with medical insurance companies, wherein the doctors write text on the papers and which are scanned for claim purposes. These are some other examples wherein we have characters written on maps, on figures, and even the music symphonies which are very difficult to identify. In order to solve these, in order to preserve all these documents, the Government of India has taken up an initiative wherein the digital library has been created, and all these are stored in the digital library and can be used as and when required. This is a very basic introduction to the image algebra that would be used in this paper. We have represented an image in a two-dimensional space called as R2 space, and the pixels are always represented between 1 to L minus 1 or sometimes even to L. We have the total number of elements that are available in the image as 2 power n, where n is equal to 8 with m rows and n columns. A grayscale image is defined as R m cross n, and a hyperspectral image is represented as R m cross n cross d, where d is generally kept with 3 because it would be easy for analysis and also for computation purposes. In our case, we have used an RGB image, and we have also converted into luminance and chrominance image. These are basic representations that have been used in our paper. The color image is represented as C of x comma y, and the conversion between color to grayscale is given as a function of C comma L, and image binarization is given as G of L comma I. These are basic color to grayscale conversions which are already available in the literature and which have been very widely used by many of the researchers. The most commonly used one is the GIMP, which is 0.3 times of R channel, 0.5 times of 0.9 times of green channel, and 0.11 times of blue channel. You can also take the average of all the three and find it as RGB divided by 3, or you can also do it the other way, like find the maximum of R and find the minimum of all the three channels, add together and find the average, or take the maximum of only RGB and compute the grayscale image. These are other approaches wherein we have the luminescence and also the optimization model, and we also can look at this as a nonlinear optimization model also. This slide particularly explains about the perpetual weight computation, wherein we have variable weights for different regions. So the idea behind this approach is to have variable weights so that the content available in the degraded image is effectively removed out. The first representation that we find over here is the first representation that we find over here is the grayscale image is equal to the color image into the fixed weighted grayscale, that is 0.3 times, 0.59 times, and 0.11 of all the three channels, which is going to give us the grayscale image. Now, writing this on a matrix form, we get it as grayscale is equal to capital X into omega, where capital X is the original image. And of course, we have a small error which actually comes into picture during this matrix computation, which is given as epsilon. So writing this on a larger matrix form, we get it as L1 to Lm as a matrix, column matrix, and an X matrix as of size m cross n, and the omega matrix of a column matrix of omega 1 to omega n, and epsilon, of course, as a column matrix of epsilon 1 to epsilon n. Now, this is we can discuss this problem in three different cases, wherein m is equal to n, when m is greater than n, and m is less than n. When m is equal to n, then there is no problem, and then the solution is quite easy. But when m is greater than n, we try to find the solution wherein we get it as omega is equal to x transpose x, the whole inverse, into x transpose into L. Similarly, when we try to find what is the case of m less than n, then again we try to find the solution wherein this will give you another unique solution. Now, what we are basically trying to do is we are trying to extract a small sample from the given image so that the weights can be computed for it, and then based on that we can try to normalize. I'll just quickly go over here. Now you can see we have we have a sample image that is given over here. So I've taken only one pixel over here. X is 255, 243, 210, and we have taken the luminescence plane wherein L is equal to 208. Using this 208, we try to compute the values of weights for omega R, omega T, and omega B, and we get it as 0.8157, and all the others are 0. And this process is continued for different regions. The choice of these regions is basically done manually. Why it is done manually? Because the human perception would be different, and that is why these regions are chosen manually. And we generally take 4 to 5 regions, and then we try to normalize all these values so that we get a global weight. Now, when this is applied to the image, then we find that the proposed approach is much better when compared to others. Now, this slide basically shows like what are the existing approaches that are available. It starts from the original image, then the weighted grayscale conversion, which is the GIMP, average, min-max, color plane optimization, luminescence, and the ground truth. So all these are shown up in this image, and this slide shows us the weights that have been computed for a given set of samples of 16 images from the DIPCO database, which was given in 2013. Now this is also plotted up as graphs, and which shows that the multiple regression method which we have tried in our paper has given much better value when compared to the other approaches which are already existing. Of course, there are certain images wherein the values have shown a very small marginal difference. However, the values, the approach seems to be much better wherein the degradation is marginally higher. These are samples wherein we find out that where we find out this is the original image, this is the output, this is the ground truth, and this is the output that we have got. So this is a binarized output, and it shows that it's much better when compared to the other approaches. Now this is a sample wherein again this is the original image. The one on the top is the original image, and this on the bottom is the ground truth, and this over here is the result that we have obtained during our approach. So this shows that the proposed approach has much better results when compared to after binarization when compared to the existing approaches. Thank you.
Good morning all. Myself Vasanta Kumari from Presidency University, Bangalore, and Dr. Arun Murugan from Presidency University, Bangalore. We are the authors of this paper on reorganizing virtual machines as Docker containers for efficient data centers. In this paper, in this work, we have discussed about how the virtual machines can be reorganized or can be made or compared as to the Docker containers for execution of the applications efficiently in data centers. Today's agenda is introduction to define the problem, literature survey, limitations of the virtual machines, that is what are the disadvantages of the virtual machines, and to overcome those disadvantages, what is the solution as a Docker container, and also discussed the advantages or merits of the Docker containers. Docker and containers are the names which can be used in Alias. Future work and conclusion, followed by the references. Cloud computing is on-demand availability of computer system resources nowadays. In recent days, virtualization of data centers have become an important topic in the technologies of IT. There are different types of virtualizations used for based on the requirement of the user. There are two virtualization technologies like Docker and virtual machines. So in this paper, these two technologies has been compared along with the advantages, merits, and also its features, and also a few steps for setting up the Docker environment also has been discussed. Traditionally used was virtual machines, but nowadays Docker has got more importance because of the characteristics and features and also its merits. Applications which are developed using containers are very easy to deploy automatically using various tools. The tools what it is discussed here are CI and CD, that is continuous integration and continuous deployment. Dockers are also considered as a lightweight because they do not require an OS per application. Applications are more secure in containers than in other technologies. What is the problem defined in our work is to conduct an comparative study between two virtualization technologies and also analyze which would be the effective technique from the perspective of the data center. Next is literature survey. This survey shows about recent trends, what are the work done. I've taken a few papers to give the literature survey. In the paper, Comparative Study of Containers and Virtual Machine in Big Data Environment, author has focused on comparing the architecture of both virtualization technologies. And observation has been made that Docker container is more convenient than using the virtual machine. In the paper Docker containers versus virtual machine based virtualization, author has focused on comparing the technologies and also its usage according to the requirement of the user. And the observation made are virtual machine provides better IaaS solution and Docker provides better SaaS solution to the end users. In the paper Containers and Virtual Machines at Scale, a comparative study is being made that in large data center environments, the deployment of application is easier in Docker containers. And also in paper Placement Architecture for Container as a Service, which is also termed as CAS in the cloud environment, the author says that the resources are utilized efficiently by using Docker containers than compared to virtual machines. We need to also know about what are the limitations of virtual machines. Security is a very important parameter that the virtual machine not provide, as there are chances for the attacker to exploit the system. The next one is overflow of a buffer. That is, it is common in nowadays in all the virtual machine because the length of the buffer is being limited. And when more number of users attempts to write more data or store the data beyond the limits of the buffer, then the particular condition what we call as overflow of a buffer will occur, which is one of the limitation of the virtual machine. And next one is, as there is one hypervisor, then there are chances of failure of the system because When one hypervisor, when everything is dependent on one hypervisor, there are chances that if that fails, the entire system also can stop working. What is the solution then? So the solution will be obviously the Docker containers. It is a tool which has been designed to run the application or deploy the applications by using Docker container, which is very easier to create. Docker also provides security to the applications running in a environment which is being shared, that obviously in networking environment. Docker also provides scalability and favor the users to run multiple applications over a single OS kernel. Containers also load the data very faster compared to virtual machines, and use of the resources varies according to the workload. So it depends on how much workload we are storing in the data center. Based on that, scalability also will increase, and also that Docker containers are considered to be suitable for multiple type of applications which are running over a single operating system kernel. And containers can start up very fast. That is, it works faster compared to virtual machines. And the resource usage also is very less compared to virtual machine. And it also depends on the load or the traffic in the data centers. What are the advantages of using these Docker containers or virtual machines? It is used as an alternative to the virtual machine because it is used as a lightweight. We can consider this as lightweight because of the number of resources. It may be CPU or memory, etc. Dockers also run on any environment supported by the containers. That is what we say. Docker containers supports containerized environment. New containers can also be created based on the requirement. Dockers are lightweight as they do not require OS per applications. And it performs very well, or it executes the applications very fast. That is why it is say that speed is one of the parameters which increases the advantage or weightage of the containers. Different levels of executions are used, like deploying, testing. So this is done faster as containers are very small. Here in this paper, more concentration is being given for comparing the two virtualization technology than how it is being implemented. Implementation part will be taken up further in further work. Here we have shown only that how the environment is being set up with a few steps. To conclude, two virtualization technologies are compared based on parameters like portability, security, etc. And also containers do not require more resources compared to virtual machines. That is one of the advantages we discussed. Continuous integration and continuous deployment or delivery tools, they automate the deployment by integrating the code written by the programmers. To conclude, Docker performs very faster or executes the application very faster than virtual machines because of less number of resources, and also in future the more security can be provided using containers. These are the few references has been made from the papers. Thank you.
Good day to all. This is Kartika M, Assistant Professor, Computer Science and Engineering from Bannari MN Institute of Technology. I am going to present a paper on the topic Similarity Analytics for Semantic Text using Natural Language Processing. Abstract. Determining the similarity among the sentences is a predominant task in natural language processing. The semantic determining task is one of the important research area in today's applications related to text analytics. The semantic of the sentences get varied according to the textual context it is used. In natural language processing, determining the semantic likeness between the sentences is an important research area. As a result, lot of research is done in determining the semantic likeness in the text. Our proposed work utilizes the term frequency based inverse document frequency model and GLCM algorithm based word embeddings vector for determining the semantic similarity among the terms in the textual contents. Also, we have utilized lemmatizer to reduce the terms to the most possible smallest lemmos. The outcomes of our proposed work is more prominent than the TF-IDF score in ranking the terms with respect to the search query terms. And also the Pearson correlation coefficient we have achieved for the semantic similarity model is 0.875, which is better than the TF-IDF score. Introduction. Semantic closeness detection is a quantifiable measure that illustrates the similarity in the meanings of the text according to their occurrence. One of the major challenges in measuring the semantic closeness in natural language lies in the way of expressing the same information in a variety of manners when analyzing the text context. Thus, by utilizing the semantic closeness model, users are allowed to less repetitively reveal the same information meaningfully when evaluating the text messages, thereby avoiding redundancy. In the network-oriented applications, measuring semantic similarity among the terms is more useful for evaluating the search queries and for retrieving the most relevant textual contents. So in the proposed work, term frequency in the textual contents with their similarity scores is achieved through term frequency based inverse document frequency model and through GLCM algorithm in combination with word embeddings based vector model. The model evaluates the textual contents with respect to the search query terms, and the similarity score is retrieved for the terms using the above said models. So for different query terms, the similarity scores are retrieved, and the most relevant textual contents containing the terms with respect to the search query is retrieved, and the same could be utilized in the applications like search engines for retrieving the semantically relevant textual contents for the search query using the proposed work. Literature review. Current research in the area of natural language processing has given valuable results to semantic relations between the sentences and the words. So here in Abney et al. In their work, they proposed or they investigates the advantages and limitations of existing methods to identify the semantic measures. They also strengthens the field of semantic web measures, and they also proposed the relevance of semantic measures to correlation methods. And Hanna Bechara et al. In their work, they proposed a semantic text similarity model using support vector machine classifier. The datasets are composed from the SEM-Eval repository. So in their model, they have compared English and Spanish sentences. So the system provides better results for English sentences compared to Spanish, with an average ranking of 33 among 74 runs and a correlation result of 0.72 for Pearson using 5 different test datasets. And semantic similarity between two words using SVM is proposed by Kartika et al. In their work. Then semantic text closeness model for Hindi language. For Hindi language, using supervised learning approach and rule-based model was undergone by Darshan Agarwal in their work for determining the semantic closeness among two sentences in Hindi language, Panian Reliance grammar, which depicts the orientation of correlated words, has been employed in their work, and it is the first system to measure semantic evaluation on Hindi sentences, and the test results provide about 79.9% correlation. So recent machine learning algorithms using natural language processing are utilized to extract actual models of similarities between the sentences and words. So word co-occurrence methods are generally utilized in the information retrieval systems. It has a list of significant words and every query is considered as a document there. A vector is framed for query sets of documents, and the related documents are extracted based on the likeness between the query vector and text vector. So this is also an recent research with respect to semantic similarity measure. So proposed model. So the best method of finding a relevant document is through searching. We all go for searching. Searching always retrieves some documents according to the keywords given in the search query. But the documents retrieved may or may not be meaningful with respect to the search query. So if the documents are retrieved with respect to the meanings concerned with the search query, then most relevant documents would be retrieved. This could be possible through various natural language processing methods. So here we try to attempt one such kind of method of retrieving the semantically relevant documents. So in our proposed model, we have utilized term frequency, inverse document frequency, TF-IDF method, and word embeddings based semantic similarity measure, and both the methods are compared against the datasets that have been utilized in a model. So before going into the proposed system flow diagram, so in TF-IDF method, what is TF-IDF method means? The words that are occurred in different text contents are ranked according to the number of times they occur in the textual context. It is one of the most elegant tools in places where occurrence of same words and necessity of words in the textual context play an important role. In semantic similarity model, the words are ranked in accordance with their similarity and not with their match. It utilizes the natural language techniques such as word embeddings to rank the words when words that overlap in the text content are small. So initially in our proposed work, TF-IDF model alone is used, and the results are gathered. Then semantic similarity measure, that is a feature vector combination, it is used, as it requires lot of function from gen library and glow algorithm. So this is the overall procedure of our proposed work. So test sequence are taken and they are separated into word sequences, then vectors are formed. Then finally feature vectors, they are formed into feature vectors, and the feature vectors are concatenated and they are undergone with different processing. Then finally semantic similarity output is obtained. So in our proposed work, two models are predominantly used. Two methods are predominantly used. The database that we have utilized is a lexical database. It is used to determine the appropriate semantic of the word in comparison with other existing techniques that utilizes a fixed vocabulary. For every textual content where semantic vector is created that contains the rank of the words in terms of weight values in comparison with the words in the second textual content used for comparison. Along with word frequency information, word frequency information is also considered. So the first step is TF-IDF. So this is a significant method for ranking similarity of the documents depending on the importance of the words present in the document. If a term is nothing but a word. If a word occurs more than once in a document, then that word is important for the document. If a word occurs number of times in many documents, then that word is not so important. The score produced by TF-IDF is based on considering the above two ideas of the frequency of occurrence of a word. So TF-IDF score helps to determine the importance of a word in a textual content. This weighting methodology is utilized by many search engines for ranking documents with respect to the search query. So this is also utilized in stop words filtering in many applications. TF-IDF is calculated based on two steps. First is term frequency TF and the second is inverse document frequency IDF. So TF is measured as the ratio of number of times the word appears in a textual content to the total number of words or terms in a textual content. Then inverse document frequency. So inverse document frequency IDF is computed as the logarithmic ratio of the entire number of textual contents to number of textual contents with that word in it. So it computes how significant a word is useful to a textual content. While measuring the TF, all the words in a textual content are considered evenly, but some words like is, that, or, of, the appears that words appears many times in a textual content, but they hold less importance. Thus, frequent words need to be weighted low than the less frequent words in a document. So the IDF is measured using the equation logarithmic of total number of textual contents divided by number of documents containing the word in it. So TF-IDF vectorization model is imported from scikit-learn package. Then that convert into group of raw textual contents to matrix of TF-IDF features. The pre-processing step of tokenization is performed by the TF-IDF vectorizer, where each word is changed to tokens. It also creates a words frequencies contain sparse matrix. Then dot product, that is linear kernel of the initial vector with the textual contents, is computed to find the similarity. The initial vector is the textual content containing the search words. So the first result, that is 1:1, is ignored because it is comparing search words to itself. Initially the stop words are ignored as they don't make good sense in the textual corpus while computing the similarity. Also, as the TF-IDF model simply determines the exact matches. For example, the words flower and flowers are not considered as same. So another approach called lemmatizer is utilized to break down each term to its reduced lemma. So using lemmatizer, the term, for example, if pomegranates are there, so it is reduced to pomegranate, and after reduction these terms are compared to its related terms in the textual content. In a dimensional space, each textual content is a point wherein the total number of dimensions in that dimensional space relates to the number of unique terms in the textual content. So this dimensional space becomes empty when the distance between the points in that dimensionality is more, which means the chosen textual content contains more number of words in it. In such cases, the angle between the document points is considered for determining the similarity. Some distance metrics like Manhattan distance, Euclidean distance could be used to determine the distance between the document points. In the proposed method, cosine similarity is used, as the output from TF-IDF vectorizer is L2 normalized. Then semantic similarity model. So this is the another approach utilized in the proposed work to determine the similarity. So that compares the textual content based upon the similarity among the terms in the textual content. Okay. So the terms in the textual contents are ranked according to the togetherness they occur in the textual content. So this model is known as GLOW model, and it is one of the word embeddings techniques. In GLOW model, the terms in the textual contents are mapped to the vectors that are creating points in the multi-dimensional space. So if the points distance in the dimensional space is less, then the terms in the textual contents occur together. GLOW algorithm is an unsupervised learning method, and it is created in 2014 at Stanford University. So for pre-processing the terms, that is conversion of terms to tokens, GLCM library is utilized. After that, this library along with tokenization facilities the removal of HTML tags if the textual contents are extracted from the web. After that, a similarity matrix is formed that consisting of similarity among each term pairs. The similarities are weighted depending upon the frequency of appearance of terms in the textual content. Finally, soft cosine similarity is measured among the search query and the textual content. The soft cosine similarity is better than normal cosine similarity as it takes into account the term similarity also. So results and analysis, the dataset is first loaded into the environment. After installing and downloading all the required packages into the working environment, vectors are formed between the search terms and the textual contents using TF-IDF vectorizer. Linear model is imported from scikit-learn metrics library for computing the similarity. Also, the stop word packages are imported from nltk.corpus package. Then term frequency and cosine similarity is computed for the search term and the textual contents using linear kernel.flatten function. So the top scoring results are retrieved from for various search terms and the same represented in the below table. See here, for the text contents pomegranate bagua, the similarity score is 0.122. So the search terms that is used here is fruit and vegetables. For fruit and vegetables, so these are the similarity score that we have achieved for using TF-IDF. So the number of textual contents that score non-zero values or 2 as they contain no matches in the textual contents, as only the plurals white onions are there. Since onion and onions are both same, the above TF-IDF model is enabled to recognize the match, and to overcome the above problem, lemmatizer is used along with TF-IDF for reducing the terms to its sorter form to determine the exact match. This lemmatizer is very much useful while plurals are there in the textual contents. For utilizing that, WordNet lemmatizer package is imported from NLTK package. The similarity outputs after utilizing TF-IDF along with lemmatizer is represented here. See here, the search terms is onions. So as the search terms is onion, white onion, the text content have higher similarity score in it. So this is the result. So it is scoring high than other textual contents. For semantic similarity matching using GLOW embeddings, GenZim library is installed along with all necessary packages in the working environment. After downloading and loading the GLOW word vector embeddings, dictionary for terms in the textual contents is built using TF-IDF model. The search term also should be in the built dictionary. Term similarity matrix is computed. Using the similarity matrix, the soft cosine similarity score is evaluated among the search term and the textual contents. Finally, the output of the textual content semantic similarity model by utilizing the GLOW word embeddings is represented in this table. See here. Using a semantic similarity model, all the scores for the textual contents is more. The similarity score is more when compared to the TF-IDF model. So for each of the term present in the search query, the most similar terms in the textual content is extracted and the results are the same or depicted in table 4. See, for the search term fruit, delicious, sweet, cherry and fresh, the text contents pomegranate bagua scores more. If for fresh, small onions text content score more. The similarity score is more. Then, so from this table reveals that what are the terms in the textual content are most similar to the search query terms. So thus the dataset is used for 2 models in the proposed work, and for our dataset containing less query search terms, semantic similarity model with GLOW word embedding showed high similarity scores compared to TF-IDF model. So the comparison result is depicted here, depicted in this diagram. So from this figure, it is revealed that semantic similarity score achieves best results. Semantic similarity score achieves best result than TF-IDF score for the chosen dataset, and the Pearson correlation coefficient achieved for TF-IDF model is 0.825, whereas for GLOW word embeddings it is 0.875. So our GLOW word embedding model for measuring the semantic similarity is higher than the TF-IDF model. Conclusion. So the model initially tokenized each of the terms to individual tokens, followed by reducing the terms to its smallest lemma using lemmatizer, and also the model utilizes term in frequency inverse document frequency approach to compute the similarity among the terms in the textual content. The semantic similarity score is computed for search query terms, and the results are compared with the TF-IDF scores. The search results shows that the semantic similarity score is more than the TF-IDF score, and the Pearson correlation coefficient achieved for semantic similarity score using word embeddings vector is 0.875, which is better than the TF-IDF score 0.825. So thus it is concluded that in our proposed model, the semantic similarity score using word glow embeddings model achieves the best results. So these are the set of references we have used in our work. That's all. Thank you.
Predictive analysis for crime in India and USA. Authors are Ms. Preeti Rachel and Professor Chelmala Selvi. In predictive analytics, data should be efficiently analyzed to predict future trends and crime rates in the country using data analysis tools. This should help us understand the impact of crimes against women in India and USA. Our aim is to use data analytic tools to understand the statistics behind the alarming state of crimes against women in our country, and we aim to use predictive tools to predict the future crime rates against women in India and USA. We also use K-means clustering to find the hot spots of crime in India. According to the National Crime Records Bureau of India, a crime against women is committed every 3 minutes, and the rate of crime has increased immensely in the past 4 years. However, data studies show that crime against women per capita is low compared to other countries in India and high in the USA compared to other countries. This information helps us understand that maybe the increased rate of crime in India could be directly related to the population growth in India, which India has experienced in the past decade. This poses the question of future trends and potential hotspots in India. The software requirements for the paper are Anaconda platform, Python 3, and Jupyter Notebook. Hardware requirements include any recent system with minimum 4 GB RAM, and that will be sufficient for such analysis. Predictive analysis is concerned with the branch of data mining used to predict future patterns and trends. This modeling technique can be used to aid society. This research aims to foresee the crime patterns against women in India. In recent years, crime against women has skyrocketed, and understanding past data can help us come up with insightful patterns that describe the current state of crime and assault in India. The data sets of the past years will be studied using extensive EDA, aka exploratory data analysis techniques that will help us understand the problems women and girls of India face. The data will then be cleaned and supervised learning techniques will be executed to predict future trends in crime rates with time. Literature review was conducted to understand the past research done on this particular topic and to understand the disadvantages and advantages of the various algorithms used in the previous papers. Now we come to the methodology. The data sets of the past years is first collected. Data collection of useful data is the first step. The data sets of past years is then explored using extensive EDA, exploratory data analysis techniques that aids in understanding the problems women and girls of India face. Comparative study of various classification algorithms has fueled the motivation to consider the accuracy provided by supervised learning techniques such as linear regression in predicting future crime rates in India compared to other countries, without limiting the study to just one state. So after cleaning using various methods to make the data more consistent, we step on to analysis. The data, once cleaned, then supervised learning techniques such as linear regression and unsupervised technique such as K-means will be executed to predict future trends in crime rates with time. The studies carried out in USA and India is compared briefly to better understand the economic bearing, if any, in crimes against women. The data sets obtained will first be analyzed using various methods of exploratory data analysis, and we will arrive at a conclusion and will help us carry out linear regression for the same. Both the countries will then be compared according to the results we obtain. We will also perform K-means on India's data to find out the safest and the most dangerous among our states for the women of India. The research aims to help the women of India by using technological advancements in the area of data science to predict the future state of the country. The data sets obtained from USA will first be analyzed along with India using various methods of EDA and aims to draw certain findings that will help us to carry out linear regression for the same. K-means algorithm will be performed on India to pinpoint the hotspots of crime against women, as it is easy and an efficient algorithm that provides near accurate results. This can help law enforcement agencies focus on these areas more and find remedies to provide a more secure environment. The Government of India provides us with the required crime data as open source, and hence we have downloaded from NCRB sites. Once EDA is performed, we move on to implementation. Manual cleaning and normalization has been done on the datasets before moving on to analysis. The first analytical method used is linear regression. Linear regression is a basic and commonly used type of predictive analysis. It's the most widely used of all statistical techniques. It quantifies the relationship between one or more predictor variables and one outcome variable by using the equation y is equal to mx plus c, where m is the slope and c is the y-intercept. We find the independent variable and substitute that to find the dependent variable y. As seen in this flowchart architecture, you can see that we have actually first identified the problem and chosen the domain. Then we have chosen the data set clearly for the project. Exploratory data analysis is then performed by using linear regression and K-means on the two countries, and a comparative study is performed. Based on the findings, we have arrived at a conclusion. Implementation. Through our EDA, we found out that the age group that is mostly targeted in India is the ages from 18 to 30. People from 18 to 30 are most vulnerable to crimes against women in India. This graph shows the statistics of crime over the decade from 2001 to 2010. There has been an increase from approximately 16,000 to approximately 22,000 from 2001 to 2010. But as you can see here, when you look at crime rates per capita in India, India falls very low compared to other countries. Once linear regression is performed, we compare the actual versus predicted values for crimes against women in India. This is the graph obtained using linear regression. Now on to result analysis. In result analysis, you can see that the regression line that we have formed has a slow slope of increase. This shows that crime in India is slowly increasing and gradually increasing. Once result analysis was performed, we used mean absolute error, mean squared error and root mean squared error values to calculate the efficiency of the algorithm. We have got the values for MAE as 0.037, mean squared error as 0.0037 and root mean squared error as 0.06. Hence proven to be an okay algorithm. Now we move on to the analysis of USA. Now let's look at this graph. It can be seen that in USA, the rape rates show a gradual decrease over the decade. The number of rapes in USA vary between 100,000 to 80,000 over the decade, which is much higher than in India. However, it has decreased during the decade. It shows the pattern of rapes over the decade from around 16,000 in the year for India in the year 2001 to 22,000 in 2010. Crime against women in India has shown immense growth. From this image, it is very clear that crime against women per capita in USA is much higher compared to other countries and very, very, very high compared to a country like India. Now once linear regression was performed to form predictive values for the crime committed against women over time, we find that the actual and predictive values for USA is as follows. When you look at the regression line, it clearly shows a decrease. The regression line clearly shows that there has been a decrease in the number of rapes in USA over the decade, while in India, the study has seen a steady rise. The regression line is now plotted in the given figure. Once this is done, we perform result analysis to understand the efficiency of this algorithm. Mean absolute error, mean squared error, root mean squared error have been performed. Mean absolute error shows a value of 0.11. Mean squared error shows a value of 0.033. Root mean squared error shows a value of 0.18. Now we arrive at the conclusion. 2 rapes per 100,000 people for India compared to 28.6 rapes per 100,000 people for the US. When we conducted linear regression for USA, we arrived at a dependent and independent variable, and we found the dependent variable to be 1537.182. which is very close to the mean calculated for USA. And for India, the mean that we calculated was about 50 rings. And we have arrived at a predicted value of 34.709 for the coming years. For both USA and India, we have seen a decrease of crime against women in the future years. USA, however, has 16 times more crimes against women than in India. And therefore, India per capita is safer than USA for women. Even if 50% of the rape cases in India are not reported and all in USA are reported, they are still 8 times unsafe. It should be noted that India has one of the lowest rates of crime against women per capita, while USA has one of the highest. The results found are alarming, yet parallel to the statistics provided every year. Now we perform K-means on the data sets of India to understand the potential problem areas or hotspots so that we can help law enforcement to tackle the problem of crime against women. First, correlation is performed. For K-means, values with the lowest correlation should be used for getting a better K-means algorithm. By comparing the correlation of the so-called variables that associate with crime against women, we choose the ones with lowest correlation for a better K-means algorithm. Once the attributes are chosen, to calculate the number of clusters required, one can form an arm shape of a graph. The elbow shows a number of 4, and hence we have chosen around 4 as the optimum number of clusters. Once K-means has been performed, you can see that we have formed 3 main clusters as the 3 potential hotspots of India for crime against women. Instead of showing 4 clusters, which included almost all the states, we decided to show 3 for better understanding. The cluster 3 consists of Madhya Pradesh, Maharashtra and Uttar Pradesh. Madhya Pradesh has an alarming number of 4,335 rapes in a year. These are the states that are in cluster 2: Assam, Bihar, Gujarat, Haryana, Karnataka, Kerala, Odisha, Tamil Nadu, Delhi, UT. These states fall under potential hotspots against crime against women in India. The third cluster formed contains Andhra Pradesh, Rajasthan and West Bengal, with approximately 1,000 rapes. However, other attributes have also been included, such as assault on women with intent to outrage or modesty, dowry deaths, hurt or grievous hurt against women, kidnapping and abduction of women, custodial rape and other rape have been considered. Thank you.
Very good morning to everyone. I'm Anand. I'm a research member in Sona Civil Image Processing Department of ECE in Sona College of Technology in Salem. And also I'm pursuing my PhD in Amrita Vishwavidyapitham, Coimbatore. So this So thank you for accepting my paper in BDCC conference. So I'm also on a part of organizing chair in a BDCC chair. So thanks for giving this opportunity to Chairperson Anand Kumar sir. So thank you, sir. So I already know, I told my paper is already accepted in your conference. That is GLCM Feature Based Texture Image Classification using support vector machine. So this is a general, not general. This is based on fabric texture images I was taken. So that is based on GLCM feature. Is gray level co-occurrence matrix extracted. I extracted feature. Then I fed it with the support vector machine that will be classified as a different problem. So before that, I want to say that what are the problem statement I am having. The first problem statement I am having to identify the different kind of error occurred while running in Powerloom. So why I am taking this problem statement in the sense. So I am in belonging to Salem district. So in Salem is majorly part of textile industries is there. In the textile industries, we have a lot of, we face a lot of problems because of a lot of error, and it's a lot of unwanted pixels and unwanted error is occurred during the manufactures of sarees or manufacture of fabrics. Then we thought why we can't do some automation. Then we came to solutions, we can do some automation this. And then we submitted this proposals to DST FIST. There is a DST FIST funded project. So this already 3 years is complete. It's a 4th year is going on. Around 1 core of this project is in our department. So this is the problem statement. Then one more problem is to define best method to classify the fabric based texture images. Then I have a different objectives. So what is the objective? To find the spatial relation between pixels. So why you want the spatial relations between the sense? We have one pixel. We have one pixel. That pixel having the fabric texture images. Okay. So in the pixel we have a different scenario. What is different scenario in the sense? We have each pixel having give one information. The pixel relation will give more information, because if one pixel to another pixel, there is a connectivity is there, definitely it will tell some information to us. That is the spatial relation with pixels. Then extracting features from gray level co-occurrence matrix. Okay, the gray level co-occurrence matrix, GLC matrix that we are extracted. Then I have the applying some machine learning algorithms to classify the fabric-based texture images. So I have done some literature survey here. So we have different methods. Methods are GLCM, histogram, and then autocorrelation. So in the GLCM matrix, we have a spatial relations with pixels with 10 statistical components. So major statistical components are contrast, energy, homogeneity, mean standard deviation, entropy, RMS, variance, smoothness, and IDM. So, but here I'm using the contrast, energy, homogeneity, and the entropy. So these are the 4 different features I applied over there. Then because it has some optimum solutions to get the result, and also it has accuracy wise, it's very better. Automated histogram method, since it has less computation, but here the noise will be more, because all the negative values will move into all the positive values. So then autocorrelation method we have it. The autocorrelation, it is to overcome elimination distortions. It has low computation complexity. So autocorrelation, it will correlate to one images to another images, but we cannot find it the accurate, because the image rotations will be happen. So even though if the image rotations happens, the autocorrelation it won't work because of rotation. It won't be matching the pixel. So this real-time applications, large images need high computation because of rotation. It is not suitable for textiles. Then we have the flowchart block diagram proposed. The first we have input image, then you have image processing, image pre-processing. So here image processing is nothing but we have converted the color image to gray level, as well as I fed it to the image resize because of SVM. Then I have it GLCM calculation, then I have segmentation, and then feature extraction. Then I am applying to the SVM based image classification. Then what is GLCM? So GLCM is nothing but a statistical method to examine the texture that contains a spatial relation of pixel. That's what we use the GLCM. It is also known as gray level spatial dependence matrix. Then we have a characteristics. What is a characteristics in the sense? It is the calculating the pixels of specific values and specific relations between occur in images as well as creating GLCM and then extracting statistical measures from the matrix. So what are the statistical measures in the sense that is different statistics we have, that is statistic features. First features will be contrast and then correlation and then energy and then homogeneity. So what is my contrast? Contrast is nothing but it is measure the local variance of the gray level concurrence matrix. It is a local variance. Then what is correlation? The correlation will be it will tell the probability occurrence of specific pixel pairs. What are the probability? Then energy is nothing but provide the sum of squared element of a GLCM. Then also known as the uniformity of angular. Then what is homogeneity is nothing but it's a distribution of element to find out the closeness of the images. That is an expression for diagonals. Then extracting other step one. The step one will be do the quantization. What is quantization? It's a quantizing image data. That is each sample on the echogram is treated as a single image pixel, and the value of the sample is the intensity of the pixel. Then it will be quantization. What is step two? So step two we have a different category. Step two will be create the GLCM. It will be square of n cross n matrix, where n is the number of levels. And then under quantization, the matrix created as follows. That is a simple sample consideration of the calculation. Then we have considered this W is a set of samples surrounding the samples and fall within the window, and that is the window size. Then considering only the sample in the set of window, defining the element to find the GLCM of two samples, that is spatial relationship between the zeros and number of levels. Then make a GLCM symmetric, that is, then make a transpose of the GLCM. Then you have to find the normalize. Why you are normalized? Whenever you are using the machine learning algorithm, data is normalized, then easily you can get a good accuracies. That is the step two. Then I use the SVM because SVM we have it 28 classes. If you have the whenever you are going to machine learning or deep learning, that machine learning if it is below 50 below 30 40 classes, we will be always the prefer will be a support vector machine, because support vector having the different scenarios. So for example, we have a two class, that is a two class with positive class, negative class. But it is more than classes, we want to put it into the feature map. So what is feature map in the sense you have 3 to 4 different classes. That 3 to different 4 classes, you have to find out the basis function. That basis function that is mapping function. That all the classes will be moving to the mapping group. So it will be splitted by linear way. Then you can find out the SVM. Then you can find out the classification. Then here the flowchart for SVM based texture. First will be image data set, and then image data set I'm splitting into training and testing. In the training I have SVM classifier, then testing you have a model, then predict you have to find out the classification. So these are the data set I used. I used 28 different data set, that is blanket 1, blanket 2, canvas, sharing 1, sharing 2, caution. That are different classes. That is the rise 1, rise 2, that is the plans. Then I use the dataset descriptions we have see here. There is a training sample I have 112 images, testing sample have 48. So totally I have each 28 classes have 160 images. So this is a flowchart of proposed texture image. First I want to do a segmentation image. Then I want to resizing the resizing image of training and testing. Then I extracted features of 20 different classes. Then I want to do system classification. Then I have classification for and performance matrix. This is the conclusion matrix for obtained 28 classes. You can see here. So in the left hand side, you have 28 classes actual class. Then right hand side, we have predicted class, that is 28 class. These are the confusion matrix which is getting from my code. So there's a prediction output I'm getting. So if I have texture image classification, if I want to make it training, then just to give it training, if training will be happen, then I have tester, I want to use some classification, it will be classes, it will be till the classes will be 28. That's the scenario. These are the general performance matrix evaluation for texture image classification. So we have 4 different parameters, that is sensitivity, specificity, accuracy, and precision. These are the majorly all the reference. I saw that a lot of references. They are majorly contributing the performance like sensitivity, specificity, accuracy, and precision. So here you can see that 28 different classes. Each class having a sensitivity, specificity, accuracy, and precision of different scenario. Then this is the conclusion of my work. First will be the texture as the image, the description of the spatial resolution. Then sample number of textures can be computed mathematically. Then method of proposed that paper combines as GLCM matrix. Then I have achieved the accuracies of 99.4 of accuracies as well as the precision to be 92.4. So further improvement of accuracies, I'm going to do increase the data set. That increase the data set of the image texture image process. This is my work. So thank you. This is my presentation. Yeah, everyone.
Good morning, one and all present here. I am Deepavati, Research Scholar, Computer Science Department, NET Trichy. I am going to present my paper title is Secured On-Demand Adaptive Routing Protocol for Data Transmission in IoT Environment. These are all the following topics we are going to discuss. First, what is IoT, then what are all the issues in the IoT infrastructure, then literature survey, our proposed model, how the proposed model is implemented. I focused mainly in IoT routing, then performance of proposed protocol, then conclusion part. First, IoT introduction. Today, Internet of Application Development demand is very high. So IoT is a major technology by which we can produce various useful internet applications. Basically, IoT is a network in which all physical objects are connected to the internet through network devices or routers and exchange data. IoT allows objects to be controlled remotely across the existing network infrastructure. IoT is a very good and intelligent technique which reduces human effort as well as easy access to physical devices. This technique also has autonomous control feature by which any device can control without any human interaction. Components of IoT. Here 4 components of IoT system tells how the IoT is working. First, sensor and devices. Sensor or devices help in collecting very minute data from the surrounding environment. All of this collected data can have various degrees of complexities ranging from a simple temperature monitoring sensor or a complex full video feed. Then second one, connectivity. The collected data is sent to a cloud infrastructure, but it needs a medium for transport. So the sensor can be connected to the cloud through various mediums of communication and transport such as cellular networks, satellite networks, Wi-Fi, Bluetooth, wide area networks, low power wide area networks, and many more. Then third one, data processing. Once the data is collected and it gets to the cloud, the software performs processing on the accrued data. Then user interface. The information made available to the end user in some way. This can achieve by triggering alarms on their phones or notifying through some text or emails. Then characteristics. Characteristics of IoT. IoT characteristics may vary from one domain to another. Some of the general and key characteristics is given below. The first one, intelligence. IoT comes with a combination of algorithms and computation and the software and hardware that makes it smart. Ambient intelligence in IoT enhances its capabilities, which facilitate the things to respond in an intelligent way to a particular situation and supports them in carrying out specific tasks. Then connectivity. Connectivity empowers Internet of Things by bringing together everyday objects. Connectivity of these objects is pivotal because simple objects level interactions contribute to add collective intelligence in IoT networks. It enables network accessibility and compatibility in the things. With this connectivity, new market opportunities for the Internet of Things can be created by the networking of small things and applications. Dynamic nature. The primary activity of Internet of Things is to collect data from its environment. This is achieved with the dynamic changes that takes place around the devices. The state of these devices change dynamically. Example, sleeping and waking up, connected and or disconnected, as well as the context of devices including temperature, location and speed. In addition to the state of the device, the number of devices also changes dynamically with the person, place and time. Then enormous scale. The number of devices that need to be managed and that communicate with each other will be much larger than the devices connected to the current internet. The management of data generated from these devices and their interpretation for application purposes becomes more critical. The report also forecasts that the number of connected devices will reach 20.8 billion by the end of this year. Sensing. IoT would not be possible without sensor, which will detect or measure any changes in the environment to generate data that can report on their status or even interact with the environment. Sensing technologies provides the means to create capabilities that reflect a true awareness of the physical world and the people in it. The sensing information is simply the analog input from the physical world, but it can provide the rich understanding of our complex world. Heterogeneity. Heterogeneity in Internet of Things as one of the key characteristics. Devices in IoT are based on different hardware platforms and networks and can interact with other devices or service platforms through different networks. IoT architecture should support direct network connectivity between heterogeneous networks. The key design requirement for the heterogeneity things and their environment in IoT are scalabilities, modularities, extendabilities, and interoperabilities. Security. IoT devices are naturally vulnerable to security threats, as the efficiency, novel experiences, and other benefits from the IoT, it would be a mistake to forget about security concerns associated with it. There is a high level of transparency and privacy issues with IoT. It's important to secure the endpoints, the networks, and the data that is transferred across. All of it means creating a security paradigm. Challenges. What are the challenges we are facing in Internet of Things? There are many benefits to the increased adoption of IoT technology, even though still many challenges to widespread IoT adoption and to a secure, functioning global device network. Security. As we discussed last, IoT devices are naturally vulnerable to security threat, even though it's giving a lot of benefits. That's why security concerns are forget to concern. But it's important to secure the endpoints of the networks. Regulation. Another common characteristics of technological innovation is that government regulation often takes a long time to catch up with the current state of technology. With the rapid evolution that's happening every day in IoT, so the government is taking its time in catching up, and businesses are often left without crucial information they need to make decision. Compatibility. New waves of technology is a good news, but it can also create frustrating compatibility issues. Compatibility for the IoT devices also depends upon user keeping their devices updated and batched, which, as we have, can pretty difficult. When IoT devices that have to talk each other are running different software versions, all kinds of performance issues and security vulnerabilities can result. That's a big part of why it's so important that IoT consumers keep their devices patched up and up to date. Bandwidth. Connectivity is a bigger challenge to the cloud and IoT than we may expect. As the size of the IoT market grows exponentially, some experts are concerned that bandwidth intensive IoT applications such as video streaming will soon struggle for a space on the IoT. Then customer expectation. If the customer expectation and product reality don't match, the result can be system failures, orphaned technologies, and lost productivity. Literature survey. Satya et al. Proposed real-time secure route analysis method for providing mobile ad hoc network routing security. This technique was considered lot of factors for making security between source and destination. The author used two types of measurements to calculate metric value for counting number of nodes in the route, and this method was concluded with single route for improving the quality of service. The main drawback is that if a single route is getting failure, no further communications will be occurred. Then Rahul and Sujata has explained about various advantages and challenges in IoT and listing the factors which are affecting the routing process. Cup carbon simulator was used for the simulation process, but this process only deals with static routing. The dynamic routing and also the implementations are very difficult. Ahmed Sof proposed energy efficient geographic protocol for avoiding region problem and also balancing the energy maintenance of concerned networks. This method was finding the single hop nearest node knowledge for forwarding the data packet. If suppose the nearest node is malicious node, then all the nodes will be hacked easily. Then Michael and Salma proposed a distributed learning algorithm for routing configurations, but this concept dealt with only local communication among all the nodes in the networks. In this paper, Badis Hami proposed multipath routing protocol, where two types of approaches are considered for finding the factors which are affecting the performance of routing, but time efficiency or not time efficiency, it's a time consuming process. And then Sharma proposed single control and balancing the load of routing. Adaptive load tuning techniques proposed to achieve good network lifetime, but this method is suffered by higher delays during the routing process. In this paper, the author has explained energy aware and secure multi-hop routing protocol. Here, author has considered three main phases for splitting the networks into inner zone and outer zone. So, this proposed techniques minimizing the routing overhead. Drawback of this concept is applicable only for WSN, wireless sensor networks, and will not suitable for heterogeneous based scenarios. PLR case Leong proposed secure multi-hop routing protocol for establishing secure transaction between IoT devices. This protocol ensures authentication before a new node joins into the group. By using multiple layers authentication, it causes memory overhead to all the nodes in the network. So, objective of our work: lot of problems in existing networks, existing papers. So, to overcome in our proposed protocol, we are going to achieve authenticated route request, route reply messages, finding secure path, and then validating the result. Our proposed infrastructure, secure the on-demand adaptive routing protocol belongs to asymmetric cryptography, where hash chain technique is used to check the authentication of the packet, and this hash function value is used for passing the updated routing informations to the neighbor nodes. If a node is getting any updated routing information, only then it will check the authentication of each, only then it will pass to the next node. Like that, the authentication of each entries of the messages is checking. The first, we are going to find the root request. Here digital signature is incorporated with root request messages. The source node S want to communicate with node D. So node S transmitting root request messages with digital signature to the next neighbor node. That node will check the signature. Then it forwards to the next neighbor node. This process will happen till reach the corresponding destination node. Here The corresponding receiver node also will check the signature before producing the root replay message. So here the node D sends root replay message after finds the secure shortest path. The proposed protocol header format is given in the figure. It has 5 fields. These fields are doing major functions of checking the authentication and find secure shortest path for the communication among nodes. This protocol, where the hash function is used for ensuring the authentication, it's generating the random number that's known as seed. This seed selecting the maximum node count. This maximum node count is used to set the time to live value. The because is used to set the maximum node count times. While processing root request and root replay messages, the hop count hashing with maximum node count to check whether the answer is same as because value. If it is same, normal communications will be continued, else the packet will be lost. If suppose that link is damaged, the error message will be generated by the nodes. This is secure transmission. The secure transmission from source to destination. We got a path by using our proposed protocol and algorithms from S to D and D to S. This is our proposed protocol. The first part explaining how the sending and receiving root request root replay messages is calculated. Then second part used to calculating the shortest and secure path. Simulation environment. The secure on-demand adaptive routing protocol is simulated by using NS2 simulator. The following simulation parameters are used to simulate the proposed protocol. This is the simulation result. This is showing the new node joins in the group. This output showing how the root request messages is broadcasted. This output showing how the verification of digital signature is happening, transmission of data packets, how the communication is occurring among multiple nodes. This output showing the result between time versus throughput. Here the green color is our proposed protocol, red color is existing protocol. So our proposed protocol giving better throughput than the existing protocol. This is showing the packet loss. Our proposed protocol reducing the packet loss than the existing protocol. So by using the secured on-demand adaptive routing protocol, we achieved authenticated root request to root replay messages, and then we got secure path between sender and receiver among all the nodes, and also this is suitable for tremendous networks. It taking less time to find the routing, secure routing between source and destination. Finally, NS2 simulator used to simulate the output. NS2 simulation results also showing our proposed protocol gives better throughput and minimum packet loss than the existing routing protocol. These are all the reference paper I have used. Thank you.
Good morning to all. I am Tasni Assistant Professor, Computer Science Department, Presidency University, Bangalore. Today I'm going to give a presentation on the topic Service Measurement Index-Based Cloud Service Selection using Order Preference by Similarity to Ideal Solution based on Intuitionistic Fuzzy Values. I'm presenting this paper as part of EAI BDCC 2020 Third International Conference on Big Data Innovation for Sustainable Cognitive Computing. And this paper is co-authored by Dr. C. Color-to-Grayscale, Dean, School of Engineering, Presidency University, and Dr. K. Venkatesh, Professor and Head of Computer Science and Mathematics Department, Myanmar Institute of Information Technology. So in this presentation, today I am going to discuss following contents. First, I will talk about the introduction, followed by objectives, methodology, then results and discussion, and then finally conclusion. So moving on to the introduction, cloud computing is the on-demand delivery of IT resources over the internet with pay-as-you-go pricing. Instead of buying, owning and maintaining physical data centers and servers, we can access the technology services such as computing power, storage and databases on an as-needed basis from a cloud provider like Amazon, Google, Microsoft, etc. So because of the success and benefits of the use of cloud services, a range of business organizations are moving towards the cloud. So the selection of the best cloud provider is a research problem and is an MCDM problem, so a multi-criteria decision-making problem. So several MCDM approaches like AHP, Analytical Hierarchical Process, Fuzzy AHP, then SAW, Simple Additive Weight Method, etc. have been proposed in the literature in order to address this research problem. So the evaluation and the selection of the suitable cloud service provider as per the user requirement is a challenging task and that needs to be addressed. So a better ranking framework is required to assist the organization to select the best suitable cloud service provider. So the ranking of the cloud service providers, especially based on the user requirements, is a challenging task. So different user requirements will be there. So based on the user requirements, selecting the suitable cloud service provider is a multi-criterion decision-making problem. So as I have told, different MCDM techniques are available and many researchers have used these different MCDM approaches in order to solve these problems. So the main objective of this research work is to perform the ranking and selection of the CSP using a suitable MCDM approach for helping the user to select the best cloud service provider based on their requirement. And the ranking of the CSP we have to perform based on a standard criterion. So a standard way of comparison of the cloud service providers is required. And in any MCDM approach, the evaluation or the criteria selection, the evaluation of the alternatives based on the relevant criteria is a challenging task. So the selection of the criteria is an important phase in any MCDM approach. So in our problem, the cloud service provider selection problem, we have used an evaluation framework which is called as SMI framework. And SMI framework is a framework proposed by a Cloud Service Measurement Index Consortium, which consists of different criteria like accountability, building, usability, performance, and security. And this SMI framework was approved and certified by ISO. So this framework is a standard way of comparing and evaluating the CSP. So we have decided to use the SMI attributes like accountability, billing, usability, performance and security as the evaluation criteria. So based on this evaluation criteria, we will be collecting the data about the real cloud service providers and then we will select a better MCDM approach in order to solve this problem. So the methodology that we have used is, we have first of all, we have selected the evaluation criteria. Of course, for any MCDM approach, we have to select a suitable evaluation criteria, a standard way of comparing and evaluating the alternatives. So here the alternatives are the CSPs, and the evaluation criteria we have selected as SMI attributes proposed by the CSMIC Cloud Service Measurement Index Consortium. And next, after selecting the evaluation criteria, we have to use a better MCDM approach for evaluating and ranking the cloud service providers. So as we know that the dataset associated with the cloud is fuzzy in nature. So in order to handle the uncertainty and fuzziness involved in the data, we have used fuzzy Topsys MCDM approach. So the uncertainty is the data we have handled using the fuzzy Topsys rather than the classical method. And as I have told that the SMI attributes like accountability, usability, security, billing, and performance are considered in this research work as the criteria for evaluating the alternatives, which are nothing but the cloud service providers. So these are the SMI attributes that we have considered for evaluating the alternatives. So in our study, we have considered around 16 real cloud service providers like Amazon, Google, Cloudware, Exoscale, etc. Then the first important phase was selecting the evaluation criteria. So these are the evaluation service measurement index attributes that we have selected in our research work. So the fuzzy Topsys method, this is the MCDM approach that we have used in our research work for evaluating the cloud service providers. And we have used the principle of linguistic Topsys combined with Intuitionistic fuzzy values in order to address the fuzziness involved in the problem. So these are the important steps in the ranking and selection approach that we have used. We have collected the data from the documentation of the various cloud service providers, their website, and various trustable online resources that gives the real data set. And after collecting the data, based on the SMI attributes, we have mapped the data as per the SMI attributes, and then we have identified the linguistic variables and the importance of each variable also we have represented using a linguistic variable. After that, we have constructed the fuzzy value decision matrix, and we normalized it, and we have computed the weighted normalized Intuitionistic fuzzy value decision matrix. Then the Topsys method, as per the Topsys method, we have to compute the distance of each alternative from the ideal positive and the ideal negative solution. And finally, we have computed the closeness coefficient of each alternative, and based on the ascending value of the closeness coefficient, we have ranked the CSPs. So the closeness coefficient, which is the alternative which is having the highest closeness coefficient, is ranked as number 1. So these are the linguistic variables we have used for rating the performance of the CSPs, and there are 4 linguistic variables: very high, average, low, and very low. So these are the linguistic values that we have used, variables and values, and then based on that we have constructed the decision metrics for the attributes like accountability, billing, security, usability, and performance for all the 16 alternatives that we have considered. From this, we have computed the weighted normalized fuzzy valued metrics, and even the importance also we have mentioned as a linguistic variable. Then we have computed the weighted normalized fuzzy valued metrics. From that, Euclidean distance from the positive ideal and the negative ideals alternatives are used for computing the closeness of coefficient of every provider. And in order to rank the services based on the value of closeness coefficient, we have sorted the closeness coefficient values in the descending order, and the cloud service provider is having the highest closeness coefficient is ranked as number 1. So this graph shows the distance from the ideal and the positive and the negative solution of all the cloud service providers. And these are the results, the closeness coefficient of each of the 16 CSPs. And it is clear from the table that the cloud service provider 14, which is having the highest closeness coefficient 0.86, is ranked as number 1. The highest, the most, the best suitable cloud service provider for the user. And the cloud service provider 13 is ranked number 2, and the closeness coefficient value is very close to that, 0.80. And the least performer is the cloud service provider 1 with a closeness coefficient value of 0.25. So these are the ranking and the closeness coefficient of all the 16 cloud service providers that we have considered in our work. This graph shows the ranks of all the 16 CSPs. So let me conclude my presentation. So as I have told that selecting the best cloud service provider among the available providers is a difficult task, because many of the organizations, due to the popularity and benefits of using cloud service providers, they are moving on to the cloud. So selecting the best cloud service provider as per the requirement is a difficult task. So the selection, we have to consider the uncertainty involved in the data set. So based on that, we have used the fuzzy Topsis method, and the evaluation criteria is also a critical component in any MCDM approach. So we have used the SMI attributes like accountability, billing, security, usability, performance as the criterion for the comparison and the selection of the cloud service provider. So in future, we are planning to extend this research in order to rate the cloud service providers based on other approaches of MCDM, and we are planning to compare all the MCDM approaches, and in order to select the best MCDM approach for solving this cloud service provider selection problem. So these are the references that we have used in our paper, and thank you so much. So I am done with my presentation. Thank you.
Hello everyone, I am Shyama R, Research Scholar, Department of Computer Science and Engineering, National Institute of Technology, Tiruchirappalli. I am here to present my paper titled A Multi-Objective Optimal Trajectory Planning for Autonomous Vehicles Using Dragonfly Algorithm. This is the overview of my presentation. First of all, introduction about autonomous driving, then literature survey, challenges in trajectory planning, proposed work TP Dragonfly, performance analysis, conclusion, and finally references. Moving on to the introduction, autonomous driving refers to the self-driving vehicles that sense the environment and make the decisions by its own without the involvement of a human driver. The advanced control systems interpret the sensory information to identify appropriate navigation paths as well as obstacles. They provide safer, smarter, and more productive travel for the passengers. Now moving on to the working of autonomous vehicles. Any autonomous vehicle is having 5 major components: computer vision, sensor fusion, localization, path planning, and control. Computer vision is how we use camera images to figure out what the world around us looks like. Sensor fusion is how we incorporate data from other sensors such as laser and radar to have a better understanding of the environment. After creating a deeper understanding of the world around us, we use localization to figure out how precisely we are in the world. Then we can use path planning to move through the world, that is from the source to the destination. Final step is the control, which specifies how we use the steering and other controls of the vehicle to control the trajectory. Next is trajectory planning problem. The path planning, what actually we do is to build a trajectory for the vehicle. The first step is planning, which generates a new route for navigation to go from the source to the destination. Routing generates a navigable path, After routing, we move on to the trajectory planning. Trajectory planning is how we make subtle decisions to avoid obstacles and create a smooth ride for the passengers. The goal of trajectory planning is to generate collision-free and comfortable trajectory to execute by the vehicle. It can be described by a sequence of points. Each point has an associated velocity and timestamp that indicates when we should arrive at that point. The trajectory planning has a critical role in autonomous driving. The vehicle must navigate autonomously and take intelligent decisions. They must determine a path for travel from the data it collects from the environment. They can consider both the static and dynamic environment. Now we move on to the lane change scenario. The vehicle considers both static and dynamic obstacle. The autonomous vehicle called the ego vehicle changes the lane when it finds a static obstacle. It considers the safety criteria and moves to the lane adjacent to it. When the autonomous vehicle senses a dynamic vehicle, then the speed of the vehicle, ego vehicle, is if the speed of the ego vehicle is greater than the speed of the dynamic obstacle in front, then it starts the lane change. The ego vehicle follows the reference path until it senses the obstacle. The lane changing scenario is shown in figure. Next is literature survey. Several algorithms have been applied to trajectory planning, and most of them are based on the searching techniques. These techniques failed in obstacle avoidance behavior. Several studies have been done to meet the trajectory planning problem for lane changing scenario in different constraints. Several optimization algorithms are used, such as ant colony optimization, genetic algorithm, particle swarm optimization, etc. But these algorithms suffer from premature convergence and local minima trapping. Some global planning approaches are also applied in trajectory planning problem. Some of these methods applied are A-star algorithm, RRT algorithm, Dijkstra's algorithm, etc. Major drawback of these methods are calculation process time. That means the trajectory calculation time. To improve the results, local trajectory planning methods are also applied, such as splines, Bezier curves, etc. They also fail to meet the obstacle avoidance behavior. Some other approaches are also applied, such as sigmoid curve based approaches and nonlinear model predictive control approach. They also have some disadvantages. Now we have identified the challenges in the trajectory planning problem in lane change scenario. So the challenges are random movement of dynamic obstacle, optimal path generation, convergence to global minima, and the time taken for the generation of trajectory. Moving on to the proposed work for trajectory planning, that is TP Dragonfly. We consider the trajectory planning for lane change scenario. The proposed work generates an optimal collision avoidance path for the vehicle to move. It uses a meta-heuristic algorithm, which is an improvement on the basic Dragonfly algorithm that mimics the swarming behavior of the natural dragonflies. It considers the safety criteria, such as when it sees an obstacle, it avoids the obstacle in both static and dynamic environments. Now, the Dragonfly algorithm, basic Dragonfly algorithm, the algorithm is based on the swarming behavior of the natural dragonflies. It forms groups only in two situations, either for hunting or for migration. They forms group for hunting, which is known as static swarm, and the swarm formed for relocation is known as dynamic swarm. This is shown in figure. The dragonfly individuals exhibit 5 primitive behaviors. First is separation, which is represented as SI. It represents the operation to avoid collisions that the individuals follow with other individuals. It can be calculated as given in the equation. Then second operation is alignment, which represents the dragonfly's velocity, which matches with other nearby dragonflies of the same group. It can be calculated as shown in equation 2. Then cohesion, which is the tendency of the individual to move towards the center of the group. Fourth behavior is attraction, which represents the attraction towards a food source. It can be calculated as shown in equation 4. Then distraction. Distraction is the distraction from the enemies. This can be calculated as shown in equation 5. The location of the vehicle is updated using step vector. The behavior of the dragonflies is as shown in figure. It shows the different behaviors of the dragonfly, such as separation, alignment, cohesion, then attraction, distraction. Now move on to the objectives of TP Dragonfly. The autonomous vehicle must traverse to the destination avoiding obstacles. The aim here is to obtain an optimal path for the obstacle avoidance for the vehicle to move. Dragonfly algorithm is initiated whenever the vehicle senses an obstacle. The global best path can be obtained after the number of iterations of the Dragonfly algorithm that we propose, that is TP Dragonfly. When the vehicle reaches an obstacle, the sensors detect it and the range of the obstacle is calculated. Dragonfly algorithm is then initiated. The TP Dragonfly algorithm is then initiated to avoid collision. It will find the best next position avoiding the obstacle while reaching the goal. The food source gives the optimal path for the ego vehicle to move. The position of the ego vehicle is updated as in equation 6. The best approximations are stored and retrieved by an archive. The food source of a dragonfly is chosen from the archive. Best food source is chosen from the archive. So the food source is always a good candidate solution. Therefore, the quality of the food source is proportional to the optimal path length. The next position of the ego vehicle always depends upon the distance between food source and the obstacle. The important factors considered here are obstacle avoidance behavior and goal finding behavior. So for obstacle avoidance, the collision avoidance is modeled using the obstacle avoidance behavior. The position of the food source is selected as the global best path, which specifies the safety criteria of the system and maintains the maximum distance between the ego vehicle and the obstacle. The objective function can be calculated as the Euclidean distance between the best position and the obstacle in the environment, which is shown in equation 7. Then the nearest obstacle to the vehicle is calculated as equation number 8. The food source must be kept in the minimum distance from the goal. The food source gives the best position. It is calculated as equation number 8. The two behaviors can be combined to find the objective function of the proposed method. It can be represented as objective function is equal to C1 into 1 by minimum distance plus C2 into distance of G minus F. Here C1 and C2 is the fitting parameters of the algorithm. This is the modified Dragonfly algorithm that we propose. So initialize the starting and goal positions of the autonomous vehicle. Then follow the reference trajectory that is generated at the path planning phase until an obstacle is sensed. If the vehicle senses the obstacle, it starts the modified Dragonfly algorithm. Then initialize the population of the dragonflies randomly. Then step vectors are calculated and the iterations are while maximum number of iterations, calculate the fitness of each Dragonfly, update the location of the vehicle, then update the weights, then compute the S, A, C, F and E using the first 5 functions. Then update the neighbor radius, velocity vector, position vector, etc. using the equation 6 to 8. Move the vehicle to the global best position. Now moving on to the performance analysis. The simulation tool we used is MATLAB Simulink. It is a MATLAB based graphical programming environment for modeling, simulating and analyzing multi-domain dynamical system. The optimal trajectory calculation is simulated using MATLAB and Simulink. Now the simulation environment, the schematic diagram of the activation of the TP Dragonfly algorithm is shown in figure. When the ego vehicle finds an obstacle, whether it is a dynamic obstacle or a static obstacle, it has to move or change the lane based on the criteria. So it actually activates the TP Dragonfly algorithm. The vehicle activates the TP Dragonfly algorithm and then it generates an optimal path which is different from the reference path. These are the parameters selected for implementation. In this proposed method, we have considered both the static obstacles and dynamic obstacles. So the graph shows the longitudinal distance and longitudinal velocity with respect to time for a static obstacle. When the ego vehicle senses a static obstacle, it changes the lane to avoid collision. It initiates the TP Dragonfly algorithm to obtain the optimal path. Next is the simulated values for longitudinal values for lane changing scenario for dynamic obstacles. The figure shows the longitudinal distance and longitudinal velocity. The speed of the ego vehicle is higher than that of the vehicle in front. If the speed is higher than the ego vehicle, then obviously the vehicle has to gradually change the lane before it approaches the vehicle in front. Longitudinal position and longitudinal velocity are shown in the graph. Then simulated values for lateral positions. Lateral position and lateral velocity is shown in this figure. It shows that for the dynamic obstacle how it moves to how it starts to change the lane. Then the figure 8 shows the comparison of the trajectories generated by our proposed method and the data that is collected from the ngsim dataset. The lane change trajectories generated by the proposed method and by the ngsim data for the vehicle ID 456 is shown in figure 7 for the static obstacle. Result analysis for the dynamic obstacle. It compares the lane change trajectories for the vehicle taken from the ngsim dataset and our proposed method. Here the ego vehicle is considered to be at a speed of 60 km per hour and the obstacle moves at a speed of 45 km per hour. As mentioned earlier, if the speed of the ego vehicle is higher than the speed of the vehicle in front, then it automatically senses the distance, calculates the distance and it starts changing the lane. Now the fitting parameters and role of fitting parameters in this algorithm. We have two fitting parameters as mentioned earlier, that is C1 and C2. The figure shows the effect of fitting parameters for both the parameters on the trajectory. First figure, effect of fitting parameter C1 on trajectory, and second is the effect of fitting parameter C2 on trajectory. Actually, the fitting parameters decides the convergence of the objective function. This fitting parameters is calculated by trial and error method, and the optimal values of these parameters eliminate the local minima. That was a major problem in other existing works. So, moving on to the conclusion, the proposed method generates an optimal trajectory for the autonomous vehicle, feasible in the generation of optimal path for real-time data, The convergence is guaranteed during the optimization since the weights are changed adaptively. It converges to a global optima value. Randomness is included. That is, we consider the random movement of the dynamic obstacles also. Now, the references. These are the references, and thank you.
Warm greetings to all. I'm G. Sandhya, working as Assistant Professor at Sri Krishna College of Technology. And my topic of presentation is Emperor Penguin Optimization Algorithm and M-tree based multi-constraint multicast ad hoc on-demand distance vector routing protocol for MANETs. The abstract of our work is multicast-based routing in ad hoc networks is considered essential for attaining reliable data dissemination. Trusted data transmission can be achieved by using optimal multicast trees that aid in better performance of the network. Prolonging network lifetime is yet another issue that needs to be concentrated for sustained connectivity. Emperor Penguin optimization algorithm and M-tree based multicast ad hoc on-demand distance vector routing protocol both are proposed for optimal selection of multicast routes for enhancing the lifetime of the network. This proposed protocol utilizes the merits of exploitation and exploration inherited from Emperor Penguin optimization algorithm with the estimation of multi-path fact multi-factor path inclusion and destination. The proposed EPOA-MT MAODV method, this includes two stages. The first stage is M-tree construction using divisional based clustering, and second stage is multicast routing using Emperor Penguin optimization algorithm. In the first method, the first stage, it includes an M-tree construction using route request and route reply scheme by using three limitations. They are multi-feature, path enclosure factor, and terminal flag. Once the M-tree is constructed, the EPOA chooses optimal paths from the available paths in the M-tree. The main goal of the EPOA algorithm is to select the solution with best fit as the optimal path for communication. The fitness function is based on the energy, delay, link lifespan time, and distance. So this is the block diagram of our proposed model approach. So here node selection, we are doing the node selection by using terminal flag, multi-feature, and path enclosure factor. So the first approach is divisional based clustering, and the second stage is M-tree construction. So we are optimizing the route selection. So we are using Emperor Penguin optimization algorithm here. Next is divisional based M-tree formation. The divisional based clustering scheme, it is a divisive scheme. It involves top-down method. The data is grouped into cluster. Further, they are divided into clusters under the entire set of data, and they are grouped into clusters distinctly. The clusters are divided based on various standards or limitations which should be satisfied by a node in the cluster. The algorithm is based on the following constraints, namely multi-feature, path enclosure factor, and terminal flag to perform clustering and to build the M-tree. The source that wants to forward a packet, it sends a RQ packet to its adjacent nodes in the communication range. Every node verifies the constraints are fulfilled to advance the data. The nodes that fulfill the conditions become a part of communication. Here, multi-feature is calculated by using the given formula. The multi-factor is based on different factors including energy, LLT, and distance between two nodes in a cluster. Here in this formula, this is energy of a node, and dt, it represents the distance between nodes. LLT is lifetime of a link, and LLT norm and dt norm both are normalized LLT and dt. So hence we are constructing the M tree. Here we are using top-down approach. Only if the constraints are satisfied, a node forwards RQ packet to the destination nodes through the intermediate nodes. Once the RQ packet is received, the destination commences the RP stage. The destination sends the RP packet to the source using the inverse path data in the RP packet. The in-between nodes forward it until the source receives the RP packet. The M tree is built with the routes formed between the source and destination. EPOA based multicast routing. So as I told you, we are optimizing the route. The optimum choice of multicast routing to forward data packet is discussed here. In this proposed scheme, the multicasting routing scheme, it is formulated based on EPOA algorithm. EPOA algorithm focuses on enhancing the processes of searching. The EPOA algorithm, it is an optimization method developed based on the inspiring features of emperor penguins. The fitness assessment of EPOA algorithm concentrates on the construction of an optimal multicast tree for transmission-based fitness assessment and multicast routing. Next is solution encoding. So solution encoding, it is the easiest method for demonstrating the algorithmic process. The goal of multicast-based routing algorithm is to send the data packets from the source to the anticipated number of destinations. Let D1 and D2 represents the destination which accept information from the source S. Many paths exist from a source to the destination, and the one with the best fitness value is chosen as the optimum solution here. And the fitness formulation, it is calculated by using the formula given here. The fitness function finds the quality of the solution. In this problem, it is based on energy, delay, LLT, and distance. The node energy and LLT should be maximum, while the delay and distance among the nodes should be minimum. Here, N is the number of nodes in the network, D is the number of destination, and P is the number of path to reach the destination. E is the energy of a node, and J, it denotes the number of nodes J path. And last, F1, it is computed by using this formula. Number of node, F1 denotes the number of nodes along a path, and it is given by this formula. So our proposed scheme, Emperor Penguin optimization algorithm, it is used there in our scheme. So this Emperor Penguin optimization algorithm, it is a meta-heuristic algorithm. This EPOA approach, it uses optimization scenarios based on their huddling behaviors. This helps them to survive in the Antarctic winter. This huddling behavior includes 4 stages. The stages include generation and estimation of the boundary of the huddle, computation of temperature profile existing around the boundaries of the huddle, estimation of the distance between the emperor penguins, effective mover relocation. So every penguin, it has the equal probability to participate in the huddling behavior according to the level of warmth. This EPOA completely focuses on the estimation of an effective mover. It is assumed that the hurdle is located on the 2-dimensional L-shaped polygon plane. Initially, the EPOA randomly generates the boundary of the hurdle. The temperature profile associated with the hurdle boundary is estimated. Further, the individual distances between the emperor penguins are determined in achieving the maximum degree of exploitation and exploration. Finally, the best optimal solution is attained, and the huddle boundary, it is recalculated such that the results are obtained to update the location of the search agents. Here the search agents are nothing but penguins. And next is generation and estimation of the boundary of the huddle. In this context, the huddle boundary is realized around the polygonal grid and it is determined based on the wind flow. But the movement of penguins are always considered to be slower than the flow of wind. At this juncture, complex variables, these two symbols are used for presenting the randomly generated Hartle boundary. And it is calculated by using the formula given here. And next is computation of temperature profile existing around the boundaries of the huddle. In this phase, the emperor penguins construct the huddle in order to save energy and improve the ambient huddle temperature. This situation of huddle construction is achieved mathematically by assuming the initial temperature. So we are setting the initial temperature as 0 with polygonal radius which is greater than 1. And if temperature is equal to 1, the polygonal radius will be less than 1. This profile of huddle temperature, it is capable of balancing the trade-off between exploitation and exploration based on different locations of the emperor penguins. So it is calculated by using the formula given here. So here RP is the polygonal radius and T huddle width. It refers to the time incurred in determining the best optimal path in the network search space. Next, in this step, the distance between individual emperor penguins and the superior optimal solution are estimated after the construction of the huddle boundary. So we are estimating the distance between the emperor penguins here. The remaining emperor penguins or the other search agents, they are responsible for enhancing the positions using the existing best optimal solution, and it is calculated by using the formula given here. So here CPV1 and CPV2 are the collision prevention factors used for avoiding collision among the neighborhood emperor penguins. S best of EPQ and SPVC of EPQ, they both represent the best optimal solution and position vector of the emperor penguin respectively. SF of EPQ is the social factor of an emperor penguin attributing towards the movement in the direction of the best optimal search agent. Next is effective mover relocation. So this is the final phase of our approach. The emperor penguin positions are individually updated here based on the determined superior optimal solution representing a mover. This mover aids in position changing of the remaining search agents in the search space through which vacation with respect to current position is attained. It is calculated by using the formula given here. So we have simulated this and we have obtained the results as given here. Energy, we are considering the energy consumption of our scheme. We have varied the mobile devices, number of mobile nodes, and based on that we have obtained this result for energy consumption. And varying the number of mobile nodes, we have obtained the link lifespan time of our proposed scheme as given here. And this is the energy consumption of our proposed scheme. We have varied the mobility speed and we have obtained the results as given here. And for link lifespan time, we have varied the mobility speeds and we have obtained the results for our proposed scheme here. So finally, I like to conclude my presentation. So this is our approach, EPOA MT MAODB protocol. It is proposed with benefits of huddle factor and mover relocation for sustaining balance between the rate of exploitation and exploration during optimal multicast tree construction process. It computes the fitness function formulated based on the factors of delay, minimum distance, link stability, and energy for optimal selection of optimal routes for reliable multicast routing process. The energy consumption of the proposed EPOA MT MAODB with varying mobility speeds is significantly reduced by 6.94%, 7.86%, and 8.94% when compared to the benchmark schemes. The proposed EPOA MT MAODB for varying the number of mobile nodes is improved by 6.54%, 7.68%, and 8.42% when compared to the benchmark schemes. So these are These are the references which we made for our work. So that's all about my presentation. Thank you all.
Good afternoon, everyone. I am Mani Priya, research scholar from Department of Computer Science Engineering from NIT Trichy, and we presenting my research work on concurrent spatial color information processing for video-based vehicle detection applications in the guidance of Professor Mala from Department of Computer Science and Professor Samson Matthew of Department of Civil Engineering in NIT Trichy. So overview of my presentation is I'll be beginning with the introduction of intelligent transportation system and its applications and the research issues in the existing work, and then be presenting about the proposed work of virtual multi-loop containers and its performance analysis, and concluding with summary and references. So an intelligent transportation system is a set of technologies that helps in sensing, analyzing, controlling and communicating traffic information to any transportation mode in order to improve the safety, mobility and efficiency. So the main objective of any intelligent transportation system is to improve the traffic efficiency and improve the efficiency of the commuters such as drivers, pedestrians and others, and improve the public safety. It also needs to improve the efficient usage of infrastructure. It has to maintain the cost savings of several motor carriers, transit operators, and it helps to improve the environmental quality and save energy. So the application of intelligent transportation system is categorized into 6 types, and they are included as advanced traffic management system applications, rural transportation applications, public transportation system application, travel information system application, commercial vehicle operation applications, and advanced vehicle control system applications. So majorly concentrating on advanced traffic management applications. So we have, this is the overall process of the traffic management applications, where we have a centralized traffic management center to which several traffic information are obtained through sensors and other carriers such as vehicle detectors, cameras, GPS, Bluetooth or reporters or weather reporters, or so all the traffic information are given to a centralized center which process the information and provides it to an user in the form of virtual sign machines or a navigation system or mobile application or traffic control system and other formats. So the major contribution in this proposed work is done for the detection process or the information that is acquired using a camera based or a video based detector. So the acquisition of any traffic information for an application of a traffic management system, so it is any data collection is done either through an intrusive or a comprehensive way, and the data collectors have sensors such as inductive loop or radar based or acoustics or any video based sensors. So the key requirement of any application of traffic management is the vehicle information such as traffic count or volume or classification of vehicles or the speed or the queue length or the headway and other information. So the core requirement of obtaining these information is to identify the vehicle, or the other terms a vehicle detection process. So acquisition of this traffic information by vehicle detection has several applications, and some of them are speed monitoring system, travel time estimation, congestion estimation or parking system, toll management system, and traffic signal control, traffic violation monitoring or autonomous vehicle operations and others. In specific, it is also very much helpful for transportation research related analysis such as traffic flow analysis or the occupancy analysis or any other maintenance of the road infrastructure. So for all these applications, a traffic vehicle identification is the core content that is required. So in specific, when we consider video based applications, so vehicle detection through video based have several advantages and limitations. So the several advantages that It has a faster response and it aids in monitoring multiple lanes for detection, as a rich array of data for visual analysis, and it helps in easy comparison of results, and it is very much applicable for autonomous vehicle detection. And the major limitation is that the maintenance of the equipment is cost is high, and equipment cost itself is high, and the storage cost is also high. So the major issues in a video-based vehicle detection is that the content of the video is the major issue here, where when during congested vehicle condition, nighttime condition, or occluded video, or deciding the threshold for detection, and whenever the traffic is heterogeneous, when multiple it is not lane disciplined or heterogeneous traffic condition, and what are the features that need to be selected to identify the vehicles, and the robustness of the image processing algorithm that has been implemented for vehicle detection are few other factors that affect the vehicle detection process. Apart from that, the other issue is that the quality and the angle of the camera that has been installed in the particular road network is also has to be taken into consider, and there needs to be a trade-off between accuracy and computational complexity. So when the accuracy increases, the computational complexity also increases. So there is a need for a trade-off, and there are several vehicle detection algorithm that is existing in the existing work, majorly defined based on the moving object detection, and they are classified as motion-based methods and appearance-based methods. And the appearance-based methods are mainly dependent on the feature of appearances, and are classified based on a machine learning or a deep learning techniques using training and testing and all those methods. And motion-based methods are of few types, such as interframe distance methods, or background subtraction, or optical flow method, which are where again are classified, where background subtraction are classified as parametric model methods and non-parametric model methods, and optical flow or also has corresponding matching or tracking based on prediction. So these are some of the classification of the existing work in vehicle detection. So the overall issues that has been seen across several diverse algorithms for vehicle detection is that first, the most of the results of the detection process are mainly dependent on the angle of the camera through which the vehicle is being captured, and the illumination factor of the video, and the static or the nature of the background of the video, where it has several movements or very minimal movement around the movement of vehicle, is also poses a major issues. And most of the existing work are applied only for a lane disciplined or a homogeneous traffic condition, and most of the works are not simple or scalable or flexible enough to be applied for multiple lanes as such, and it comes with a high computational cost for an highly accurate detection process. So these are some of the existing issues in the existing work. And also the other important factor is the place or the framework through which the entire detection process occurs also needs to be analyzed, where most of the work are comprising of entire image being processed, and very few has a grid based or a sliding window or a zone based detection, or a selected region based detection, or pixel based detections. So the overall problem description and the objective of the work is to have first is to have a solution and that provides an optimal balance between computational complexity and accuracy, and the method needs to be robust enough in order to have an irrespective of the environmental condition, and it has to handle an heterogeneous traffic condition, and it needs to reduce the manual labor when considering a traffic transportation researcher's point of view. And as a part of a traffic management, since this detection process is not an entire application, it is actually a part of the application, traffic management application, so it has to be made simple and flexible. So this is the proposed framework for detection of vehicle, which is known as a virtual multi-loop containers. So it is comprising of several grid-like patterns, or in other terms, each grid is known as a box, and it has a each layer sequence of box is known as a loop. So each layer, so we have a multi-loop system here, and each loop or the entire process of detection happens only in the middle layer of the loop. As you can see, it has been the entire process of detection occurs only in the middle layer loop, and the middle layer is being detected separately. We can see that in the next few slides, and it is also considered that it is seen that the HSV color model seems to be the better or the best performing color model for an outdoor traffic condition. So each box or each container is being identified as a separate image and converted into an HSV color component or the hue, saturation and value component. So the overall detection process using the proposed VMLC container loop is that first the detection zone is being selected and a few user preference is being inputted, and then the direction of motion is identified through which the middle layer loop is being identified, and then the image processing or the vehicle detection process occurs, from which the traffic information such as speed or vehicle count or classified count has been enumerated, and then later it is made available for any application that requires these traffic information using a video based method. So the major significant feature of the proposed VMLC is that it decreases the entire computational space, that is it only makes sure that the entire process occurs only in the middle layer loop. So any background that has a complex movement is been converted into a static movement or a simple disturbance available, so which leads to a minimizing the false positive rates, and it can be easily integrated to any vehicle detection process for which uses a video based methods. And this entire VMLC structure can also be used for classification of vehicles and also to identify the speed of the vehicles. So these are some of the advantages of the proposed VMLC method framework. And first, as a first section, the direction of motion of the vehicles is being identified. So the direction is being determined using the histogram of the different loops using an earth movers difference method, distance difference method. So we can see that the different frames at different condition has different histogram for the same location. So we can see that the direction is being identified as a movement from left to right or right to left or up to down or bottom to up, and based on these movements the middle layer among these loop is being selected as a middle layer loop, and all the processing is done only in the middle layer of the proposed VMLC. And for the next step as the vehicle detection, the vehicle detection in this research work is done using background subtraction method, where we have a background model through which the foreground frame or the current frame is compared, and whenever there is an subsequent movement in the frame, it is being identified as a foreground mask. So a background subtraction technique is used to identify the image processing technique is being used for identifying the vehicles in this method. And the other innovative concept that has been used is that when we use HHV color model, all the color components have been used simultaneously, as the most of the existing method convert the RGB color model into either a gray level or a binary level, but whereas here the three color components are being simultaneously used, especially in parallel fashion in order to identify the vehicle. And so the background subtraction is separately done for hue, saturation and value component, and then the background image is being upgraded parallelly using the parallel updation methods. And for vehicle classification, it is done using a heuristic method of identifying the number of boxes that is being detected with vehicles, and it has been heuristically identified as a two-wheeler, a three-wheeler car and HSV color model. And for simulation, we have used the Visual C++ with OpenCV library files for image processing tools, and OpenMP library files for parallel methods. And this is an overall screenshot of the proposed VMLC, and we have used a D-track data set and a few of the other traffic videos captured from Chennai Rajiv Gandhi IT Expressway, and we can see that the process is being done only in the middle layer loop. And this is a screenshot of how the parameters for the histogram value detections and how the traffic count, classified count displays. So it's a screenshot of the method. And so when we compare the simulation results, the comparison is done for videos which have very low traffic condition, medium traffic and high traffic condition. And we have also compared the detection for frameworks such as an entire image or a selected region or the selected region with grids and the proposed method. So we can see that the detection of an entire image is very high when compared to the proposed method, and it was also seen that the detection process for a very high traffic condition is very much high for an entire image. It does not, it mainly because the entire image in an entire image detection, the detection occurs for any simple movement that occurs in the video, so which we can see from using a false positive. So we can see when detection process for an entire image, the false positive rate is very high, and the proposed method shows a very least false positive. So the proposed method ensures that the proposed framework ensures that the detected vehicle in the proposed method has at least false detections. So we have also compared it with that of a dynamic background video where there is more movement, and a static background video where there is less movement, and we can see that the false positive is very much minimal in case of the proposed VMLC. And we have also compared the storage that is required for the process and the speed, the number of frames per second, the speed in processing. And we can see that when processing in parallel, we can see that it almost the storage is almost similar in case of an parallel and a sequential VMLC. And we can also say that the storage is very much less because the process is occurring only in the computational region of VMLC, which is only the middle layer loop, whereas we can see the entire frame, the storage is very much high because it has to store the details about the entire frame. And similarly, comparing the processing speed or the number of frames per second that has been processed, it is seen that the number of frames that has been processed for VMLC is very high when compared to entire frame or the other detection method. So it is seen that the number of the processing speed of the algorithm is very much high for every frames per second. This is the overall comparison of the different types of videos that has been taken, and their corresponding detection number of vehicle that has been detected is also being shown here, and the threshold for the detection or the EMD threshold that is being used for the background subtraction is also being shown here. And the dataset DTAC dataset, which is being used with other state-of-the-art methods such as YOLO and other faster RCSN was also compared here, where it compares with other different types of videos such as rainy video, very easily detectable video, or a sunny video. And we can also see that it has been shows a very less detection rate for nighttime and rainy video and hard or difficult to detect video. So but it performs an overall consistency of detection is being shown using the proposed method. And the overall result from the simulation is that there were around 30 videos which has been analyzed for this proposed method, and the maximum error rates for the videos with adverse climatic conditions such as rainy conditions or very gloomy condition, and for the nighttime traffic videos. So an overall error rate was up to 13.2%. So coming to the future work, it is seen that we are trying to implement machine learning algorithms for the proposed VMLC and the parallel method, and it is we are trying to fine tune the framework to improve the speed in detection, and we are trying to improve the detection process by introducing novel pre-processing techniques for detection. And there is also an analysis of how an automation of threshold can be done is also been the next part of a future scope, and simultaneously multiple VMLC is also been attempted, and a polygonal shape is also been tried. for VMLC. So the conclusion is that I have proposed a new framework known as virtual multi-loop containers, and it shows an efficiency in acquiring data, and it helps in easy integration on any vehicle detection process with the video based application in ITS, and the performance has been tested using DTRAC datasets and other traffic videos, and an overall detection accuracy was around 83.8% with a processing speed of 28.3 frames per second. So these are the references that has been used. And thank you.